In this video, you can find some of the important difference between questions and physics second PUC. Do watch it, and if you find this video helpful, please don't forget to subscribe. Difference between diamagnetic materials and paramagnetic materials. Diamagnetic materials are weakly repelled by the magnets, whereas paramagnetic materials are weakly attracted by the magnets. The relative permeability is less than 1 in diamagnetic materials. Relative permeability is more than 1 in paramagnetic materials. Susceptibility is low and negative in diamagnetic materials. Susceptibility is low and positive in paramagnetic materials. Diamagnetic materials do not obey Curie's law, whereas paramagnetic material obeys Curie's law. Magnetization is low and negative in diamagnetic materials, whereas magnetization is low and positive in paramagnetic materials. Difference between ammeter and a voltmeter. Ammeter is a device that is used to measure current. Voltmeter is a device that is used to measure potential difference. Ammeter should always be connected in series in the circuit, whereas a voltmeter should be connected in parallel with the resistor. The resistance of the ammeter should be low, whereas the resistance of voltmeter should be high. The ideal ammeter resistance is 0. The ideal voltmeter resistance is infinity. A galvanometer can be converted into ammeter by connecting a low resistance in parallel with it. A galvanometer can be converted into a voltmeter by connecting a high resistance in series with it. Difference between intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor is a pure semiconductor crystal, whereas extrinsic semiconductor is a semiconductor doped with impurities. In intrinsic semiconductor, number of electrons and holes are equal, whereas in extrinsic semiconductor, number of electrons and holes are unequal. In intrinsic semiconductor, conductivity depends only on temperature, whereas in extrinsic semiconductor, conductivity depends on temperature and impurities. In intrinsic semiconductor, conductivity is due to both electrons and holes, whereas in extrinsic semiconductor, conductivity is mainly due to majority charge carriers. Difference between N-type semiconductor and P-type semiconductor. N-type semiconductor is obtained by adding pentavalent impurity atom to pure semiconductor, whereas a P-type semiconductor is obtained by adding a trivalent impurity atom to pure semiconductor. In N-type semiconductor, electrons are the majority charge carriers, whereas in P-type, holes are the majority charge carriers. In N-type semiconductor, holes are the minority charge carriers, whereas in P-type, electrons are the minority charge carriers. Example for N-type semiconductor is germanium doped with arsenic. And example for P-type semiconductor is germanium doped with indium. Difference between interference and diffraction. In interference, the intensity of all bright fringes is same, whereas in diffraction, the intensity of all bright fringes is not same. In interference, the intensity of dark fringes is 0. In diffraction, the intensity of dark fringes is not 0. In interference, the width of all the fringes is same, whereas in diffraction, the width of all the fringes is not the same. And interference occurs due to superposition of two or more light waves, whereas diffraction occurs due to superposition of secondary wavelets starting from the same wavefront. Difference between nuclear fission and nuclear fusion. Nuclear fission is a process in which a heavy nucleus splits into two nuclei of comparable masses along with release of few neutrons and energy, whereas nuclear fusion is a process in which two lighter nuclei combine to form a single heavy nucleus along with the release of energy. Nuclear fission can take place at room temperature, whereas nuclear fusion takes place only at high temperature. In nuclear fission, energy released per kilogram is small, whereas in nuclear fusion, energy released per kilogram is large. In nuclear fission, products are harmful, and in nuclear fusion, products are harmless. Difference between inductive reactance and capacitive reactance. Inductive reactance of a coil is defined as the ratio of RMS value of voltage across the coil to the RMS value of current through it, whereas capacitive reactance of a capacitor is defined as ratio of RMS value of voltage across the capacitor to the RMS value of current through it. Inductive reactance is directly proportional to the frequency of the AC. Capacitive reactance is inversely proportional to the frequency of the AC. And inductive reactance XL equal to omega L, which is equal to 2 pi FL. Capacitive reactance XC is given by omega C, which is equal to 1 by 2 pi FC. Inductive reactance XL equal to 0 for DC circuit, whereas capacitive reactance XC is infinity for a DC circuit.